So you've graduated from engineering and it's finally time to start earning the big bucks and begin working as a full-time engineer. You get a job, you get into the office, you get your first project, and then very quickly realize that you have no idea what you're doing. That was me a little under 2 years ago. Now, by no means am I saying that I've got everything figured out now, but recently in my office we've had new interns and graduates join the team, and for the first time in a while it's been super clear to me just how far I've come. Although some of the things I've learned, I really wish someone had just told me sooner because it would have saved me a lot of time, stress, and confusion. So in this video, I'm going to be the person that I wish I had and share with you the 8 things that helped me to survive my graduate years. Alright, so number 1 is manage your emails. In the construction industry, everyone communicates through emails. This means you'll be getting emails from architects, builders, clients, project managers, other engineers, your colleagues, and literally anyone else in between. And very quickly, all these emails from various people about various projects are all going to get mixed together within your inbox. And unless you get a system set up, you're constantly going to be wasting time finding old emails, and you're not going to be able to keep on top of where things are at within each of your projects. Now, how I like to organize my emails is to sort them into 5 different categories. These categories are design, construction, complete, events, and personal. How this works is basically whenever I get a new project, I create a new folder under the design category and then name that folder whatever the project is called. From that point onwards, any email I get about that project goes into that folder. All throughout the design phase, I'll keep this project folder within the design category, and only when I've issued the construction issue drawings will I then grab that folder and then move it into the construction category. When construction has ended and no one has contacted me about this project for a while, I will then grab this folder and move it into the complete category, where I'm basically just storing the conversation history. I found that progressing projects through my emails like this is a really great way of keeping track of where my projects are at, and it also really helps to separate them out a bit more so it's less overwhelming. Also, one more thing that I want to mention about this process is that I'm not only putting the emails I receive into each project's folder, but I'm also putting every email I send into the project folder. I like doing this so I have a complete conversation history, as sometimes people take ages to reply to emails and I easily want to be able to see what the last message sent was. Okay, and in the other 2 categories I haven't mentioned yet, which is the events and the personal category, in the events category I'll put any emails about special presentations or lunches that are happening, and then in the personal category I'll put things like any resources people have sent me or anything I want to save and keep track of for later. Alright, next is ask an annoying amount of questions. This piece of advice I received about 10 months into being a graduate engineer, and when I first heard it, I felt so relieved. The engineer that gave me this advice also said that if you aren't asking a lot of questions, people will think that you're not doing any work because your seniors do remember how tough it is to be a graduate. He said absolutely no one comes in knowing exactly what to do, so to sit there and pretend like you know what you're doing, you're only really fooling yourself. My advice on this is much the same. Ask as many questions as you can while you're still a newbie, because if you're still asking simple questions when you've got like 4 or 5 years experience because you were too shy or you had too big of an ego, only then will people think that you're stupid. Okay, and number 3 is keep a copy of all your calculations. Whether you like to write on paper or do your calculations on a note-taking app on an iPad like I do, you need to store all this work. Often changes are made by the architect or by the builder during the design or construction phases, and if you have your calculations handy, you'll be able to quickly backcheck them and make sure that the change that they're proposing still works with your design. On the other hand, if you haven't kept a copy of your calculations, you'll literally have to redo this work, which is going to get really time consuming and annoying. So if you are doing your calculations on paper, make sure that you scan those files when you're done and file them on your computer, and likewise if you're taking your notes digitally, make sure that you've got them saved and backed up so they're easily accessible. Alright, and number 4 is sketch details yourself. For those of you that don't know what a detail is yet, it's basically a detailed drawing with annotations that shows exactly how 2 or more structural members are connected. For most new engineers, including myself, this is where most of the difficulty comes in our designs because we just don't have much knowledge on typical connections. Although what I've found is that by sketching out to scale what I'm trying to connect, often it's a lot easier to figure out what I need to design for and ultimately what's possible. Details are definitely where a lot of the creativity in structural engineering can come from, so don't be afraid to sketch out something new and then get it checked by a senior engineer. Okay, next is make a library of details. What I mean by this is that every time you sketch out a detail or you come across a good set of details done by another engineer, copy it into a PDF and start building a catalog. Having your own library of details really speeds up the design process, as you don't need to sketch out new details every time, and over time you really get familiar with the details that that are in your catalog, and it becomes a lot easier to just reuse them on new projects. Likewise, I found that when I get stuck and I can't really picture how two things are going to come together, looking back at my old details really gives me inspiration and helps me figure out what I can do in this new situation. Now, how I actually went about building a library of details is literally just creating a bunch of A1 blank pieces of paper in a PDF editor, and then over time, as I would sketch new details and come across new details done by other engineers, I would then just copy those details onto these pieces of paper and then group all similar ones together. Alright, and number 6 is get out to site. Unless you've done internships and gotten this experience while you're a student, most graduate structural engineers have never been to a construction site. Getting out on site allows you to see how things go together and also starts to teach you what different building elements are called. Besides that, it also teaches you why you need to have safety factors in your design, because you'll start to see that things are never built exactly how they were designed. Although one of the biggest advantages of going to site as a graduate is that it gives you a lot of practice on how to read structural drawings. This skill in particular is definitely something you'll need to learn how to do fast, and if you do want an introduction on how this is done, I have made a video on this topic and I'll leave a link to it in the description. Hey everyone, I just wanted to give a quick shout out to a new friend of the channel and the sponsor of today's video, SkyCiv. In case you're not familiar with SkyCiv, it's a cloud-based structural engineering analysis and design program that runs completely from your web browser. This means that unlike traditional software, there's no installation or software updates required to get started, because all you need to do is open up your web browser and be connected to the internet, and then you're good to go. Now, SkyCiv has several design and analysis modules that can help you with the design of individual members and their connections, and it also has a 3D FEA frame software that allows you to model entire steel frames as well as concrete structures. One of the things that SkyCiv has done really well and makes it stand out from other structural engineering programs is how intuitive and friendly the user interface is, and also how quickly you're able to master the entire program. For example, inside the design and analysis modules, you can do simple analysis of things like beams and trusses with just a few clicks. And even more intensive tasks like steel and concrete, you can just flow through these modules with very little effort. SkyCiv also has many of the codes embedded within its design modules, so regardless of whether you're designing for Eurocodes, the ACI, or Australian standards, it's super easy to check whether your design complies with the code. Another thing that's really unique about SkyCiv, and something that I can really appreciate, is how it doesn't hide the calculations from you. In every module, regardless of whether it's analyzing a simple beam or something more complex like the design of a reinforced concrete beam, after you run your analysis, you're given the option to open a PDF which fully outlines each step of the calculation. In terms of pricing, SkyCiv offers a range of different plans both in month-to-month and contract formats, and they also offer heavily discounted plans for students. So whether you're a student in your studies trying to get ahead or a professional engineer looking to design more efficiently, be sure to check out SkyCiv using my link in the description to see the power of this program yourself. Thanks again to SkyCiv for sponsoring this video, and let's get back to it. Okay, next is always have a go first. What I mean by this is that before you go over to a senior engineer and ask for help, always see if you can come up with a solution first, or at least have an idea of what you would do before you go over. Senior engineers want to see that you're trying to problem solve yourself first and aren't just coming straight to them for the solution. I've found that often if I can show the effort I've put in before going over and asking for help, they'll be a lot more enthusiastic about helping me. And you know what? Sometimes when you just wing it and you just throw something together, you'll be surprised by how close you actually were. Alright, and number 8 is create a second brain. What I mean by this is that when you learn how something's done or someone gives you a tip, you need to take note and document whatever it is so that you don't have to keep relearning the same thing and asking the same questions. This learning summary that's full of explanations, calculations, and advice will become your second brain. For example, say one of the senior engineers has come over to your computer and shown you how one of the features works within one of the design programs that you're using. After the engineer leaves your desk, you need to note down exactly how that feature works and what buttons you had to press to make that feature do whatever it was, so that you don't forget and you know exactly how it's done for next time. Keeping notes and summaries like this takes a lot of strain off your brain, and honestly this one simple trick has allowed me to design a lot more confidently and a lot faster. Personally, I built my second brain in OneNote with some things on the app Notability on my iPad, but for some people I've seen them just do this in a Word document or in a physical notebook, and I've also seen people use the app Notion. If you are just starting out, I would encourage you to look into Notion, because I think Notion offers a really unique way to do this, but just do whatever way is going to be easiest for you. Anyways, I hope you learned something from this video, and if you did enjoy it, you might like this video here where I take you through a day in my life as a structural engineer, or that video there where I talk about how I would learn structural engineering if I were to start over. As always, thank you so much for watching, and I'll see you in the next video. Bye bye.